Okay, hopefully your quiz on Friday went well. Today we're going to start talking about the difference between independent and dependent and compound probability, which means more than one thing happening at a time. Before we do that, we need to talk about a principle called the fundamental counting principle. It says that if M occurs in M ways and N occurs in N ways, then the event of M followed by N is M times N ways, which is kind of a little confusing, but it's really pretty simple. Example, if we have two different entrees at a restaurant that we can choose from with three different drink possibilities, then 2 times 3 would give us 6 possible lunch specials. So to visualize that, look here. If we have entree 1, we can have 3 drinks with it. So that's the first entree with drink 1, the entree with drink 2, or the entree with drink 3. Or we can choose entree 2 with each drink, giving us 6 total options. So 2 times our 3 gives us 6 options. Looking at this deli, it says, how many different types of lunch specials are there? There are 6 different types of sandwiches you can choose from, 4 different sides, and 5 different drinks. 6 times 4 times 5 is 120. Try the you try. It says, suppose a computer generates passwords that begin with a letter followed by 2 digits, like R38. The same digit can be used more than once, which is important. And how many different passwords can the computer generate? So there are 26 letters in the alphabet, and then 10 digits, 0 to 9 are 10 numbers. So then that would be 26 times 10 times 10, which is 2,600 different passwords. If we could not use the digit more than once, all that would do is change this from 10 and 10 to 10 and 9 so that it wouldn't repeat the number that was used here. Any questions on the fundamental counting principle need to be asked at this time. Now, let's think about it. Looking at this example, suppose you're flying from Philly to San Diego. The weather forecast for each city is shown in the picture, so it looks like in Philly it's going to rain today but be sunny tomorrow. In San Diego it's going to be cloudy both days. What is the probability that it will be raining in both cities today? We have an 80% chance and a 50% chance. So these are things to take into account. This is an example of a compound event because it is made up of 2 events happening at the same time. Before we do anything, we have to determine if these events are independent or dependent of each other. So does the rain in Philadelphia have anything to do with the rain in San Diego? Probably not, because they're on different sides of the country. So, in your own words, real quick, in the table on the next page, write down what you think the definition of independent and dependent are, in your own words. Independent doesn't change your sample space, whereas dependent does. The probability definition of independent is an example, like rolling a dice and flipping a coin. Independent means they have nothing to do with each other. They're completely on their own. Rolling a dice and flipping a coin. If you roll a dice and get a 4, that doesn't mean anything about when you flip a coin. However, dependent means that you're dependent on something happening. So it does change your sample space. They have something in common. An example would be drawing a card, not replacing it, and then drawing a second card from the deck. So in the example, we're going to decide whether each of the outcomes of the trial are independent or dependent events. So remember, independent means the sample space doesn't change. Dependent means the sample space does change. So the first one, if we choose a number from a tile of 12 and then spin a spinner. Tiles and spinners have nothing to do with each other, so that's independent. Picking a card from a deck and then not replacing it but picking another card. Because we didn't replace this, we're not left with 52 cards, we're left with 51 cards. So that would be dependent. And then in C, you flip a coin once and get heads. Flip a coin a second time and get tails. That coin, even though it's the same coin, getting a heads and a tails, they don't affect each other at all. So that's independent. Now take a moment and try the you try. Oh, excuse me, there's a D. One student is chosen in your class for a project, then another student is chosen. That's dependent because you can't pick the same person twice. Now try the you try. The first one, you select an M&M from a bag of candy and you eat it. Then you select another M&M. This is dependent because you ate the first one, so it changed the sample space. In B, you roll a standard die 2 times. The first roll is a 2, the second roll is a 6. Again, you did not change the sample space. You still have a chance of getting the numbers 1 through 6, so that's independent. If you have any questions on independent or dependent, now is the time to ask. Okay, so now we're going to look at some independent events and how to determine their probabilities. So looking at a coin toss, when you have one coin, you can get heads or tails. When you have 2 coins, you can get heads, 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 tails, tails, heads, tails, tails. So you have 2 possible outcomes with 1 coin, whereas you have 4 possible outcomes with 2 coins. So the possibility or the probability of heads with 1 coin is 1/2. The probability of heads twice with 2 coins is only 1/4. Why is the probability of getting heads twice not 1/2 or 1? Well, if it was 1/2, that would mean you would have 2 out of the 4 possibilities here, which it's not. 1 would mean no matter what, when you flip those 2 coins, you're always going to get 2 heads, which we know is not going to happen. The idea is they're independent events. Flipping a coin or 2 coins have nothing to do with each other. What this brings about is our key concept. If A and B are independent events, then the probability of A and B happening is the probability of A times the probability of B. So and means to multiply. Likewise, the converse is also true, meaning if the probability of A times B is the same as the probability of the A and B happening, then A and B are independent events. You are going to be given independent events and asked to find the probability of certain things occurring. And you are going to be given events and ask yes or no, are they independent? So this key concept is the first rule for today that you need to memorize. Now let's look at some examples. The first example in finding each probability says you spin a spinner divided into red, green, and blue parts of equal sizes. Then you flip a coin. What's the probability of getting green on the spinner and landing a coin on tails? So, getting green on the spinner is 1 out of 3, and the coin landing on tails is 1/2. So the probability of doing both will be 1/2 times 1/3, or 1/6, which is 16.6 repeating percent. Pay attention to what your directions say as to how you should write your answers. 90% of the time we're going to see probability as a reduced fraction. So 1/6 would be your answer here. The next question says a desk drawer has 5 red pens, 6 blue pens, 3 black pens, 24 paper clips, silver paper clips, mind you, and 16 white paper clips. If you select a paper and a pen and a paper clip from the drawer without looking, what's the probability that you select a blue pen and a white paper clip? Well, there are 6 blue pens out of all the pens, and there are 14 pens total, so that would be 6 out of 14. And then there are 16 white paper clips out of the 40. So you would say 6 times 14, or 6 over 14 times 16 over 40, and that would give you your probability, which is 6 out of 35, or 17.1%. Third problem, you roll a standard number cube and spin the spinner at the right, so the spinner here. What's the probability that you roll a number less than 3 and the spinner lands on a vowel? Well, on a standard number cube, there are 6 numbers. 2 of them are less than 3. That would be 1 and 2. So the probability of rolling a number less than 3 is 2 out of 6, times there is 1 vowel, the U, out of the 4 spots. So 1 out of 4 is the probability of the spinner landing on a vowel. Probability of both happening would be 2 out of 6 times 1 out of 4, which is 1/12, or 8.3 repeating percent. Next, you are asked, probability of event A is 0.35. Probability of event B is 0.2, and the probability of A and B is 0.07. Are they independent? Well, remember our rule says if we multiply these two and get their intersection, then they're independent. If we multiply them and don't get it, then they are not independent. So 0.35 times 0.2 is 0.07, so yes, A and B are independent events. Now pause the video and try the U-try. Whoop, sorry. E is not a U-try problem. Here, when you multiply them, you get no, because 0.4 times 0.28 is not 0.12. Now pause and try the U-try. Alright, so the first problem consists of pulling a marble out of a bag. You replace it, which is the words that imply that they're independent. You have 3 red marbles, 12 green marbles. What's the probability of getting a red and a green? Well, 3 out of the 15 are red, and then 12 out of the 15 are green. So 3 out of 15 times 12 out of 15 is 4 out of 25, or 16%. A coin is flipped 4 times. What's the probability of flipping heads 4 times in a row? So that would be a head, 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 head. So 4 heads in a row. The probability of getting a head is 1/2 4 times. So it's 1/2, 1/2, 1/2, 1/2, all multiplied, which is 1/16, or 6.25%. If you have any questions about basic independent probability, now's the time to ask Ms. Lewis. If not, let's talk about what it means to be dependent. Remember, dependent changes the sample space. One thing will depend on another. Something is being affected. So let's look at the first little example, illustration. We have marbles that we're drawing from a bag, 3 red, 6 blue, and we want to determine the probability of drawing a red marble on the first draw and then another red marble on the second draw without replacing the first one. So if I were to illustrate this picture, this is what it would look like. This is our original bag, 3 red, 6 blue. This is our bag after we've drawn 1 marble but not put it back. There are only 2 red because we're assuming the first one's red, and then there's still 6 blue. So the probability is dependent because our sample space went from 9 to 8. It says, what's the probability of red being drawn on the first draw? That's 3 out of 9 because there are 3 out of the 9. So that's 1/3 or 33 1/3%. The probability of drawing a red marble on the second draw in this bag is 2 out of 8, which is 1/4 or 25%. And then how do you think you could find the probability of doing them both? Well, all we do is we multiply because of the word and. So 1/3 times 1/4 or 1/12. So the key concept here is if A and B are dependent events, then the probability of A and B will be the probability of A happening times the probability of B after A. So again, anytime you see the word and, it means multiply. And this time we have to pay attention to our second fraction and how the sample space has been changed. So, some examples. Looking at a snack cart, because we all like to eat. There are 6 bags of pretzels, 10 bags of chips, so 16 bags total. Grant selects a bag at random, and then Iris selects a bag at random. What's the probability that Grant will select a pretzel and Iris will select a bag of chips? Well, 6 out of the 16 are pretzels, so that is Greg's probability. And Iris has chips, but there are 10 chips, but because Greg already got a bag, then that means there's only 15 to choose from. So Iris's probability is 10 out of 15. The fact that they are choosing together would be 6 out of 16 times 10 out of 15, which is 1/4 or 25%. The next question asks, there are 5 boys and 5 girls in the class. What's the probability that the student chosen first is a girl and the second is also a girl? So that would be 5 out of 10 for the original, but then there are only 4 girls left to choose from out of 9 because you've already chosen a student. So 5 out of 10 times 4 out of 9 is 2 ninths.